All right, this is Brandon Young, and here we're going to do the Lab 4 Exercise 1. So here what we have is we have our Arduino code and our processing code, which was provided earlier, and through that we're going to be able to get our processing values displayed on our graphs. So if I minimize these, you can see the nScope as well as our graphs going, and you can see this is all functioning properly. So now that we have these going, we actually can look at our tables. Alright, so now that we have our tables, first of all, we can start off with a screenshot of each of the different values. So if we sort of scroll down very smoothly, we can see all of our amplitude spectrum plots as well as our outputs we are reading from the nScope. So as we arrive now at our table, whoops, don't want to overshoot that. Our tables, here we notice both from our VSA, there's some slight differentiation between our sampling rate desired values, as well as some differences in our Nyquist and aliasing rates. So if you notice in particular on 75 Hertz here, we can see that the alias, theoretical experimental for 75 Hertz, notice these are both going to be 75 up front because the value of the sampling rate is more than double the value of our frequency we're trying to test for. But if we can note to the end of it, for 142, 100, or 69 and 49.5 on the right side, we notice that they are now dropping. This is because we notice that the sampling rate is no longer double that of 75. This is causing some aliasing to happen. So we can notice this trend growing as well in our other values, 100, 215, and 300 Hertz, as we notice this sort of aliasing happening. Each of these you can see are calculated on these values right here in order to show there's some aliasing occurring. So now that we've figured this out, we can move to exercise 2. All right, so this is the beginning of exercise 2. Here we have our triangular wave in nScope. If we look at our output here in processing, we notice the output here, sampling rate 99 Hertz. And so we sort of look at this and we can think about how triangular waves work. Primarily that triangular waves are sort of a summation of a few sine patterns here. If you notice, original sine waves are sort of more like triangles in that the shape is also very pointed. However, they sort of have rounded peaks and troughs. So in this one, what you do is you actually combine them, a couple of these terms together, and they create more pointed ends, which create a more triangular wave. So we're going to notice this different pattern show up when we do our square waves. So for our square wave portion of exercise 2, we notice the nScope is giving an output of square waves, as well as we're noticing an output here in processing. So square waves are kind of interesting in that they are actually a combination of sinusoidal and cosinal waves added theoretically to infinity. So if we notice our amplitude frequency here, amplitude spectrum plot, you actually notice sort of it tapers off like that as a result of this. Our first couple terms are showing up out of these peaks in our amplitude spectrum plot, but if you notice going forward, it sort of gets lower and lower. And this is sort of a result of the increasing infinite shapes of our equations that add up to these square waves. So that is sort of an understanding of how to do these sine waves as well as our triangular waves and our square waves. So now we will move on to the next lab, Lab 5. See you all next week.